All right, today we're looking at lesson 1-4, which is going to be perimeter and area, specifically in the coordinate plane. So we're going to go over just a reminder of naming of some figures. We're going to go over some reminders of formula to find perimeter and area of specific types of figures, and then we'll look through some of those examples. So in your notes, we're starting with 1-4, perimeter and area in the coordinate plane. Okay, so first thing we need to talk about is polygons, right? A polygon is a figure formed by 3 or more segments. Those segments we call sides. Okay, and those are listed below. Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, dodecagon, and then anything after that is listed with a number, right? So if it has 13 or more sides, we just call it like a 15agon or whatever, okay? Because it is possible to have that many or more. All right, then we're going to talk about the two different types of polygons we have here. We have convex, and then we have concave polygons. Okay, so let's name this one A, B, C, D, E. Okay, and somebody tell me what type of polygon this would be based off the number of sides.
Pentagon.
It is a pentagon because it has 5 sides. And how would we name this based off each side? Similar to how we named like a triangle, we call ABC. So this we would call what?
We can name all of them.
Mm-hmm.
So A, B, C, D, E.
Yep. So we would just say it's pentagon, A, B, C, D, E. Okay. All right. Let's look at this one. We're going to go call Q, R, V, S, T, U, X, and Y. So we name each point. Now this figure is called concave because it caves in at 2 different places. Okay, this one is convex because it does not cave in anywhere. Okay, so how would we name this polygon based off the number of sides? It is an octagon because it has 8 sides. And how would we name this one?
U, X, Y, Q, R, V, S, T.
Yeah, it doesn't really matter where you start, okay? As long as we name each one. Okay, and then does anyone remember what all of these points are called? Yes, vertex, or if there's more than one vertex, we call them vertices. Right, vertex is here, so plural means vertices, okay, if there's more than one. Okay, let's talk about the difference between perimeter and area. Perimeter, when we talk about perimeter, is what are we specifically talking about?
Addition.
True, but like, what am I finding if I'm finding perimeter?
Area.
The outside, right? So the distance around. Okay, so the easiest way to explain this, right, is if I want to put a fence around my backyard. I need to know the perimeter because I'm going to fence in the whole backyard. Agree?
Yeah.
Okay. If I want to find area of my backyard, what would that be for? If I was going to put down what? What do you normally have in your backyard?
A dog.
Grass, right? So if I'm going to put sod in my backyard, I would need to know the area, which is the number of square units enclosed within a figure. Same thing in this room, right? Carpet. If I want to carpet this room, I need to know the area of the floor, right? How many square units the floor covers. There's trim, there's this carpet trim that goes around this room. That would be perimeter, okay? So Those would be the distance difference in those two things. Okay, so we're going to go through real quick. We're going to talk about formulas for each of these things, these three types of figures, because they're what you'll see the most, and then we'll look at some examples. So if I have a triangle, a three-sided figure, does anyone know how I find the perimeter of a triangle?
A plus B plus C.
A plus B plus C, right? On any figure, if I want to find perimeter, can I just add the sides together? Yes, right? If you can't remember the exact formula, you just add the sides, okay? So on the triangle, we add A, B, and C. On a rectangle, you could add the four sides. On a parallelogram, you could add the four sides, okay? I will give you other formulas for those, but that will always work, okay? All right, what about area of a triangle?
1.5 base on side.
Come on, somebody remembered it.
What was that,
Right? Half area of the base times the height. Sorry, or it's half the base times the height. Area is that. Okay? So now, when we look at a triangle, how do we know what is the base and the height?
Or the right angle.
They always form a right angle every time. Okay? That's how we identify base and height. Okay? All right, what about rectangle? Anyone remember either perimeter or area formula for a rectangle?
No.
Area should be the easy one. Length times width is correct, okay? Now, what about perimeter?
2 times L plus 2 times
Perfect. Twice the length plus twice the width. Now, I talked about earlier, is it possible for you to just add the four sides together? Yes, but what do I know about these two sides right here? They're equal, so can I not double one of those sides? Yes, same thing here. The width has to be equal, so that's why you could use twice the length plus twice the width, or you could add length plus width plus width.
Why does the top and bottom have 2 lines and the sides have 1?
What does this mean right here? They're congruent, right? So that means this side is the same as this one, but why can I not put one line on this part
They all
the same as W, right? So the double bar just denotes that these two are the same, right? But they're different lengths than the width. Is that helpful?
Yeah.
Okay, good question. All right, last one, parallelogram. Same thing. Now, instead of using length and width, what do we use here? Just B and C, right? But is B down here the same as this length up on the top? Yes. Those are showed by the arrows. What about C? Yes. So same thing, I could say twice B plus twice C, or just like with a rectangle, you could add the four sides. Anybody know area of a parallelogram?
Meaning with the right.
Good. Base times height. And just like a triangle, base and height have to form a what? Right angle every time. Okay? All right. Here's the part where it can get just a little tricky, and we'll use some of the information that we learned last week to kind of help us with this. Okay? What does example 1 ask us to find?
The area of the triangle.
Okay? The area and perimeter. Okay? Wants us to find perimeter first. So in order to find perimeter, I need to know the length of these three sides. Do I know those lengths? No. Is it possible for me to find them?
Yes.
Yes. Can anyone tell me how?
Count.
On one of them, I agree with you. Only one. Which side?
MK.
MK. That is correct. You can count. You could start at M and count 1, 2, 3, 4, 5, 6. So I do agree. We're going to call this length 6 here. I'll change that to this so you can see. Okay? Now, why can I not count on these two? They're not vertical and they're not horizontal. Okay? So how would I find the length of those two lines? Something we talked about last week and you took a quiz over.
x1 minus x2 squared plus y1 minus y2 squared.
What formula are you using?
Distance.
Distance formula, right? If I have 2 points and I want the distance between those 2 points, I have to use distance formula. So first thing we're going to go over here and do is name our ordered pairs. So my first ordered pair here is at -2, -2. N is at 3, 4. K is at 4, -2. Okay? So first, let's do MN.
-2 plus
So let's write our ordered pairs up here just so we have them written, because sometimes that helps us kind of see it a little better. Okay, what two numbers do I subtract first? -2 minus 3, and then do what to that? Square it. And then I add my y values. What y values am I subtracting? -2 minus 4, also squared. Now, a lot of us really did a pretty good job with distance formula on our quiz. Some of us, though, tried to use distance formula when it was asking about midpoint. Okay, so we have to be able to distinguish between the two. All right, what is -2 minus 3? -5 squared plus -6 squared. Now, what type of number do I always get when I square something? Positive. So what's 5 squared? So is -5. What about -6 squared? 36. Okay, so we get the square root of 61. We're going to round that to the 10th place. So MN is going to be equal to... Anybody have their calculator? 7.8. Okay, so over here I'm going to label this 7.8. All right, I'm almost to where I can easily find these two things. What's the last thing I need to do? Yep, I need to find the distance from N to K. Do what?
But you use different numbers.
That is true. Yeah. So we are using 3, 4. What other ordered pair? 4, -2. Okay. Same steps. Somebody besides Austin, tell me, what am I subtracting for X? 3 minus 4. Okay. Somebody else tell me, what am I subtracting for Y? 4 minus -2. Thank you for saying minus a negative. That is correct way to start off writing this. Okay. 3 minus 4 is going to give us -1. Somebody said that correctly. 3 minus 4 is -1. 4 minus a negative changes to addition, so that's going to be plus 6 squared. Okay, we all know 1 squared gives us 1. 6 squared is 36. So I just need to find the square root of 37.
Like
6.1. Okay. So, truthfully, have we even started to do either of the two things they asked us for? No, right? Because it asked us to find perimeter first. So now I have my 3 sides. So all I have to do to find the perimeter is add 7.8 plus 6.1 plus 6.
19.9.
If we're in a coordinate plane, we call it units. We do have to label when we talk about perimeter and area. Okay? All right?
Okay.
Questions on that?
No.
Am I finished?
No.
No. What else did it ask me to find? Area is half base times height. And we talked about base and height form a right angle. Does it show us where the right angle is? No. So what do we need to do? We need to figure that out, right? Where's the base located? Bottom at 6. So what I need to do is from the very top, drop a dashed line here, because I know that forms a right angle. Agree? And since that's a straight line, I can count. What's the distance from N down to the bottom?
1, 2, 3, 4, 5,
also 6 units. Okay? So all I have to do is replace my base and my height with 6. What's 6 times 6?
36.
And what's half of 6?
18.
18. How do I label this? Yep.
Squared.
Square what?
Unit.
Units. Or you could put units squared. I would accept that also.
I would just do squared.
Yeah. Square units or units squared. Okay?
Now we're done.
Well, with that page.
Yeah.
Here's the good news. I know our notes are a little long today, but I'm not giving you homework. All right? We're going to finish through these examples, and then we're just going to practice a couple things together, and we'll be done today. Okay? All right. How do we feel about this example?
Pretty good.
Yes? Okay? All right. Okay. Example 2. Example 2 asks us to find the perimeter and the area of the parallelogram. So same things that it just asked us, okay? Again, though, one of our sides is a slanted side, so we will have to use distance formula again, okay? Somebody tell me what we already know, though.
They're gonna be the same.
Okay? The 2 sides on the top and then the 2 sides on the side are going to be the same. Can I find the distance of the top and the bottom side?
Yes.
Yeah, by doing what?
Counting.
Counting, right? I can count from K, 1, 2, 3, 4, 5, 6, 7, just to check. 1, 2, 3, 4, 5, 6, 7. So we know the lengths of those are going to be 7, if you want to write both of those. We also know, because it's a parallelogram, we know these 2 sides are the same. So when I find the length of one, do I have to use distance formula to find the other? No. I can say that it's the same. So somebody tell me, let's do LM. Ordered pair of 4, 2, and 3, -2. All right, who can set this up for me that hasn't gone yet today? Go for it, Rowdy.
Squared.
Square root.
Do what?
Yep, go ahead.
4, 2 squared.
4 minus 2.
Minus 2. Yeah.
Okay, you're close. You started with the correct number, 4. So we subtract the other x value. What's the other x value?
4 minus 3.
4 minus 3. Good.
And then 2.
Good.
Minus -2.
Perfect. Yeah, very good. Okay, so remember, x, the first x minus the second x, and then our second set, y1 minus y2. Okay, Rowdy, what's 4 minus 3?
1.
So I get 1 squared. 2, this turns into plus 2. What's 2 plus 2? Still under my square root. Okay, 1 squared is 1. 4 squared. Good. Okay, so we add, we get the square root of 17,
4.1.
which is about 4.1. Okay, very good. So that means both of our sides here are equal to 4.1. Now, this one's a little nicer to us because we don't have to do the distance formula 2 times, correct? Now we can go straight to perimeter and area. So remember, on perimeter, we're going to do twice the length. What was our length? 7 plus twice the width of 4.1. Okay, what's 2 times 7? 2 times 4.1. All right, we add those and we get 22.2 units. Now, just like the last one, we have the base. Do we have the height? No, but we can find that, right? That forms a right angle. What's that distance? 1, 2, 3, 4. Okay, so perimeter here is just base times height, right? So 4 times 7. What is 4 times 7? And we label it square units. Okay.
I'm not lost. Why did you
Where at, Aixa?
for BH?
For BH? Where did I get those 4 and 7?
No, G.
I didn't. I wrote the wrong thing.
Whatever.
Sorry. I was doing area. I was just on the wrong place. Are you less lost if it's area here?
Yeah.
Okay.
Why didn't you do one?
Because it's not a triangle.
Oh, okay.
Yeah. The only time we'll use half, because do you guys know why triangle is half base times height?
No.
Because they have a space height or something?
So what type of figure is this? A parallelogram. And how do we find area of a parallelogram?
Base height.
Base times height. What happens if I cut this in half? What do I have?
I'm trying.
2 triangles, right? So if I wanted one of those, it's half of a parallelogram. So that's the reason area of a triangle is half base times height. Okay? Sorry to confuse you on that. I just was seeing perimeter above and just was rolling with it. Okay? All right. Questions on this one?
No.
Okay. Last one. Now this one's a little extra from our other ones, okay? Because it doesn't give us anything. We have to draw all these things in. Okay? All right. Given 3 lines, x is equal to -3, y is equal to 2, and y is equal to -3x plus 4. They intersect to form a right triangle. Find the perimeter and area of the triangle. Okay? So what's the first thing I'm going to want to do here? Draw those lines. Okay? Does anyone remember how to draw x is equal to -3?
No.
Oh, come on. Somebody from my class last year should know this. Austin? Not really smack him, but somebody get his attention. Remember where we're not starting that habit again this year?
Sorry.
Can you remind us how to plot the line x is equal to -3?
You go 3 to the left.
3 to the left. 1, 2, 3. And it crosses only the x-axis at that point, so it's a line like this.
I thought it was something harder.
Well,
Come on, y'all.
He was just confusing us.
no, I'm not trying to confuse anybody here. Okay. What in the world? I'm just going to draw a dashed line for now until we make this figure. Okay? Can you guys see that okay? Did I change the color?
Okay.
It's okay? All right. Okay, so if x equals -3 is a vertical line, what would y equals 2 look like?
This way.
Horizontal, okay? Horizontal line at +2. Okay, here's the real kicker. Does anyone remember how to graph a line that's already in slope-intercept form? Y equals -1/3 x plus 4.
You go to +4, then you go down.
Come on, you're making me proud today. We go to +4, which is our y-intercept, and then we use -1/3, which is the what?
Slow.
Slope, to find our next point. So from 4, where do I move?
Down 1.
Down 1,
Then you go to the right.
right 3. Down 1, right 3. And then we're going to put that line. Sorry, I need to move this so I can. Ooh, that's not going to be very good. Bye. I'm going to try something different on this one. Hold on. Let's see if this will let me.
Symphony's confused.
Okay, hold on. What's up, Sim?
He wants to know, she said, I'm confused, how did he get that?
How did I get what?
The line, where did it come from?
Because this is in slope-intercept form, right? Y equals mx plus b. Do you remember that from last year?
No. Mr. Morris didn't.
No, don't say that. I know he did, because we all teach the same thing, okay? Y equals mx plus b, right? M is my slope, the number in front of x. B is the y-intercept, the number at the end, okay? So if my y-intercept is at +4, I go up to +4 on the y-axis, and I put a point. That's what I did first, okay? Then I use my slope, which is rise over run. So it's -1, so I go down 1, right 3, put a point. Down 1, right 3, put a point. Okay? We kind of remember that from last year.
No.
Don't lie to me. You're supposed to say yes Or do lie to me. Say you remember it.
I didn't draft any of it.
Yeah.
Do what?
I didn't draft any of it.
Well, we're going to some this year, so we gotta learn it. Okay.
I just-
Well, I understand.
I
Especially, here's the deal. There's a lot of forms I understand, but slope intercept form we have to know. Okay. Because you will use it a lot.
I just controlled like the disaster and just got one function on instead of you know.
Y'all wear me out.
Too much.
Okay.
I knew I was getting it wrong.
Yeah.
Even if I did try.
All right. This is what we're finding. This inside here. Okay. Now, on this one, can I easily find two of my sides? Yes. Okay. So, let's label these points though, so we kind of know where they're at. So we have -3, 5, -3, +2, and 6, 2. So how far is it from -3, 2 to -3, 5?
3.
This distance here is 3 units. What about across to 6, 2?
9.
9 is correct. Okay, so the only one I'm going to have to find is the distance from -3, 5 to 6, 2. Okay. Symphony, what am I going to have to use to find the distance between those 2 points?
Oh, do you want me to like?
Yep.
Oh. Hold on. Sorry, I'll write it down.
You're fine.
Yeah, the square thing,
Okay.
and then -3 minus 6 squared
Okay.
plus 5, subtract 2. and
Also squared. Good. Okay. -3 minus 6, we get -9 squared. Plus 5 minus 2 gives us 3. We know -9 squared is going to get a positive. Positive what number? 81 plus 9. Okay, so all I need to do is find the square root of 90, which is about 9.5. Okay. All right. So now that I have all the information I need on my triangle, what two things is it asking me to find? Perimeter and area. Macy, do you remember how to find the perimeter of a triangle?
1/2 times. Oh wait,
You're on area. Perimeter, you just do what?
adding
Yep. Add your 3 sides. So what 3 sides am I adding, Macy?
3 times 9, or plus 9.
Good.
Plus 9.5.
Perfect. Yep. Perimeter, we just add those 3 sides up. We get 21.5 units. Ava, what about for area?
1/2 base times height.
Okay. And what am I plugging in for my base?
9.
And the height? Thanks, Ava. Okay. Now, Ava, tell me though, how do you know to use 9 and 3?
Because they make a right angle.
Good. They make a right angle in that corner. Okay. 9 times 3 is 27. Half of 27 would be 13.5. Okay. Questions on this? Feel okay?